I think all businesses to some extent should read the report, especially those who don't necessarily think that next generation connectivity is relevant to them. We found that it is these more physical industrial sectors that stand the most to change from next generation connectivity. We found that there were a number of commonalities behind those who had successfully adopted connectivity in general, and those are certain things like hiring the right talent, getting on board the right expertise, experimenting, setting up labs, making investments, and that kind of thing. I think some of the early adopters would be energy in particular, which is a sector that we found that placed the most value on the strategic importance of 5G in particular. Other sectors might find that there are more barriers, there's more uncertainty about why they should be adopting it, and there are more risks and costs to weigh up. And then there are other sectors like digital businesses who will be adopting almost naturally owing to their existing business. We're seeing a number of different business models emerging. We're seeing, particularly because of the ability to connect a range of devices, that some firms are moving to a sort of as a service model where they are leasing products rather than selling them. There are also particular opportunities in healthcare and digital healthcare to decentralize how healthcare is provided. In the past, connectivity has been a huge force for social and economic change, and often we don't know what those marginal gains in connectivity, faster speeds of coverage and so on, might lead to, but we're already seeing that some sectors are really starting to invest in the idea and bullish about what it might bring.
WiredScore runs Wired Certification, which is a digital connectivity rating system for the commercial real estate industry. So what that means is we rate individual buildings on how well connected they are to the internet. We founded about 5 years ago in New York, and we've since opened offices in London, Berlin, and Paris. I think one of the interesting things that we're seeing is that while in the past the internet was important to businesses, in the future it's going to be the fundamental lifeblood of modern day business. While it might not be something that people think about every day, when it goes wrong and when it gets frustrating, it can be enormously annoying for businesses. The average business loses about $300,000 for every hour that the internet goes out. So landlords need to really make sure that they understand how well connected their office buildings are, so they can attract the kind of occupiers that they want now and in the future. The property sector is having to respond quite quickly to the changing business models that occupiers are demanding and the digital connectivity requirements that have been caused by that. If you think about your average building, it's a really big fixed asset. Where, however, if you look at the way that the modern economy is changing, tenants demand more and more flexibility. Modern businesses are changing all the time. They don't know what they are going to need in the future. So one part of a real estate company's response to that can be great digital connectivity, because that gives you the kind of flexibility that a big building otherwise doesn't have. In the past, we've seen business models causing requirements for new digital connectivity. Moving into cloud computing has meant that people really need the same kind of upload speed as they have download speed. So you've needed to move away from slower copper technologies and onto synchronous fiber technologies. In the future, we're going to see that even more. As people adopt artificial intelligence and augmented reality and virtual reality, they're going to require much faster speeds and much lower latencies to allow them to take advantage of future business models. WiredScore calibrates the way in which we rate buildings to each local market that we're in. One of the interesting things that we normally look for in buildings is that they have diverse power feeds, so that there's very little chance that the power will go down in a building. However, when we started working in Berlin, we worked out that the only place that you could actually be able to get diverse power feeds was right along the line of the old Berlin Wall, being fed from the East German power station and the West German power station. These are the kind of nuances that we need to take into account when making sure that we're really reflecting the lived experience of tenants. I think that digital connectivity is incredibly exciting right now because it's going to underpin what a lot of the modern world looks like. We don't know what the business models of the future are going to be, but I'm absolutely certain it's going to rely on fantastic next generation digital connectivity.
We're asset managers, and the function of an asset manager is to make sure that the owners of assets get the full value possible from those assets, from their investments, and that we make those assets live and work for as long as possible. We do this work mainly in the renewable energy sector, in solar farms, batteries, some wind farms. We do it in Spain, Italy, Portugal, Ireland, the United Kingdom and Australia. Some of our biggest challenges are around connectivity. We have to deal with different types of software in a plant that's in different locations, sometimes very remote, and we have to then bring huge amounts of that data back, sometimes on unreliable communications channels, and then we've got to clean that information. That means storing it so that in its raw and manipulated form, it's available for audit, and then people can take assurance from that information and take important business decisions arising from it. One of the things that we first had to do was figure out, in a very heterogeneous world of data sources coming through different software from different types of component, first of all, we had to create what we call our canonical database. And our biggest challenge was bringing everything back to one database where we could give it a common structure, a common naming structure, and then from that begin to work out what it all meant. So we've invested a great deal in being able to interrogate very heterogeneous systems and make it all come back into one common platform, and from there make it available to our clients. There is no amount of next generation connectivity that I'm not interested in. If you talk to me about 6G tomorrow, I'm interested in that already. I don't want to have to push my way in to people's databases, nudging others out of the way or conflicting with them about what time of day I'm trying to get my data. I want my data and I don't want to fight about it. And I want to invest in that, or I want the environment around me to become more sophisticated. And then I also know that as soon as I get my hands on that, and then I've converted it into more business value, that I'm going to have to share that quickly with people who are just as hungry for the manipulated data as I was for the raw data. I want to operate in a business environment where sharing data is not a challenge. We can put our efforts into making some business value for our clients out of it. Interoperability for us is the first conversation we have with somebody new that we meet. We want to know that they've got an API and that we can work with them or they can work with us. But we don't want barriers anymore. We understand the world it's a heterogeneous world. We don't expect that everybody has built their systems to suit us. You can build your systems whatever way you like, but make it possible to communicate, and then we can all be interoperable and we can all share, we can all make progress. Next generation connectivity in the energy sector is all about finding balance. You've got variable demand being met by variable supply. And in all of that, you've got different producers, generators, different figures all operating at the same time, trying to make sense of a market that every day has to balance. You cannot have an energy market that's out of balance. So what you want in all of the different behaviors that are happening is that if we all communicate in real time at the right level of detail, we can cope with each other. Let's make it easier to cope with each other, and we can all behave whatever way we like. Sometimes you see 5G arriving on the horizon, and in time to come 6G will arrive as well, and everybody's expecting a big win. I'll be happy if we can achieve an accumulation of small wins. The accumulation of small wins means that if I've got to visit 1,000 sites a year, that I know that the workers are safe because I know where they are, I know what they're doing when they're on site. I can work out the condition of the components in real time. I can accumulate more data about more performance of more components, and then from that work out what its predictive maintenance needs are. All of that just means a series of one little win after another that altogether make a big difference in a market that operates at very tight margins.
I mean, Ericsson builds connectivity out for the world's networks, and in the IoT team, we make sure that things are connected, and that's a new angle to connectivity. Connecting things is going to bring huge demands on the network, but in fact, the networks are adapting quite fast. We've adding 5G capability soon. This will add sort of faster response times, much higher capacities, but we're also adding capacity at the low end with low power coverage, which will be good for when you need batteries or things in places where no one's going to go for 10 years, right? So the capability is being stretched. I think networks are absolutely going to be able to cope with the capacity needed, but where we see a need to develop further is if you look at your smartphone, the sort of apps you have and the massive amount of apps available, that's not working the same way in the IoT world. And that's because there is not the same standardization in the operating system or the chipset as we have in the smartphone world. We need to get to that point where app developers want to develop things for things or applications for things. Yeah, well, we see that digital transformation is really a hot topic in the boards and the C-levels of industries all over the world right now, because they're looking at how can they evolve their product beyond what it is today. Today, products are manufactured. They tend to be sort of physical things, But inside it's software driven, and increasingly it's the software which adds value to the product. Now companies want to be able to add new functionality more frequently to the product. It means your product needs to be connected over the air for over the air updates, right? And the second thing you might want to do is then, instead of sell a product, you might want to lease it on a monthly basis, provide it as a service, and that offers a whole new way of engaging with your customer too. So I mean, now if we see everything connected to each other, this raises sort of opportunities and issues. In terms of opportunities, IoT world is not yet scaling in the same way as the consumer world had, so it means costs are a little bit higher. We'd like to see us reach the point where there are more standards in the operating systems on devices, or the semantics used for programmers to address devices. Once we get that critical mass going, I think there'll be enormous fast take-up for IoT connectivity. And one of the turning points might even be augmented reality. When we get glasses or things which are really convenient, suitable, and do the job, and we can overlay the digital world as we walk around, I think that would be a game changer and would boost things quite quickly. So I mean, when we talk to companies, we see quickly that they first want to connect their products, but that's to pull up the transactional data that the product generates. And this is huge amounts of data, what the report calls the data deluge. But it's not the data alone. Yes, it can be used for analytics and insight. It can be used to improve the product. The real value comes from data when you share it with other companies, share it with your customers to enable innovation. So really it's all about what data can we share. And then we need to balance the need for innovation, which needs the sharing, with what data do we need to protect for our company confidentiality, and balance that with what do we need to protect of our customers' privacy. So that discussion needs to be had with all the players, and it's a very important topic right now. The benefit of next generation connectivity is probably things we don't even know right now. I mean, what is happening? What has happened in the past is we've had the digital world made available to us. Then we've started to overlay the digital world onto the physical. So now fleet cars have map systems, sort of cars on the dashboard that enables the ride sharing, which is now transforming the logistic industry, not just the taxi industry. But what's coming next is embedded connectivity, where the digital and the physical world really come together. And I think that's just going to open up a whole new bunch of capabilities from our products, which we can hardly even know yet.
Well, the data deluge, in my opinion, is both an opportunity and a threat, at least if you don't get it right. I mean, with all the data that flows from connected devices, the first question you will ask is this personal data? And since that's a very broad concept of personal data, the question is whether the privacy regulation kick in, and if they do, you have loads of compliance obligations which you need to observe. So this can certainly be a pain, this can certainly restrict you in the way how you can use data, etc. So therefore, you really have to be careful to be compliant with the laws. On the other hand, of course, it's a huge opportunity. This is also one of the results from the report, where 80% of the respondents say that the biggest opportunity they see from IoT, which is basically enabled through new connectivity, is a more sophisticated data analysis, data analytics. So there are loads of opportunities analyzing all these data, putting them together from different sources, and drawing conclusions in order to improve products, to improve services, etc. Exploitation of big data for commercial purposes is a complicated thing, actually. You need to look at, can you do it in a compliant way? How can you comply with data protection law requirements? So you can avoid all these complications if you only deal with anonymous data. And now I see that's really a tricky point, because in the beginning sometimes data is attributable to an individual, and then you have to anonymize the data. And there we see those anonymization concepts. They bring about, in many cases, agreements which you conclude, for example, with certain providers of technology, just to ensure that you don't get access to certain data which could lead to identifiability of the data. So you have these anonymization agreements. Certainly you have data sharing agreements. So once you have a data set which you can commercialize, there's no ownership right in data. So you can't rely on a right to certain data. You have to conclude agreements which set out who is allowed to use certain data, for which purposes are they allowed to use them, what technical measures need to be implemented, and also under which circumstances must data be deleted, for example. The main legal issues around exploitation of big data, as I said, the first thing is really, am I entitled to use the data? Is it my data actually? For example, if you look at the connected car and the data that's produced in these connected cars, a very valid question is, who's the owner of the data? Who's allowed to use it actually? Is it the car manufacturer? Is it the operator of the car if you have a fleet? Or is it the driver? So, and coming from there, you first have to solve the question of, am I allowed to use the data? For which purposes am I allowed to use it? So it's data ownership, basically. You certainly have data protection law aspects, data privacy. What are the boundaries? Do I need a consent from the affected individuals, or do I have a legal basis, a contract, for example, for which I can use it? So I think these are the main two aspects. But also there are competition aspects, for example, because I can use this data to shut out competition. For example, if I use the data to direct a driver of a car to a certain garage, because I know from the data that flows from the car in the course of predictive maintenance that in 100 kilometers the brakes will shut down, and then there can pop up a screen and say, okay, go to this garage now, and so I can also try to cut out competition, which raises competition aspects as well. So loads of legal issues actually. I feel positive about the next wave of connectivity because I think, in my personal view, actually the opportunities really weigh out the threats, and it's just something that will be coming, and businesses have to adapt to those developments. And these are just interesting business models, and they'll affect our day-to-day life. I mean, we're already used to using a smartphone for many things, but with the advent of the Internet of Things, I think it will be very, very interesting to see all these connected devices and the possibilities you have. And it also brings about new business models and new opportunities, which really are for the good. For example, there's the huge project we are assisting with around. It's a big data project in the healthcare field, where the purpose is to improve medicine for cancer, because you're using all this data from different sources to be able to get better treatment. So I think there's also many good things about this.